Okay, here I am. I'm sorry about the delay. There's always one. There's a little click I don't make. I make, and here we are. Hello. I see people are here already. Appreciate it. Been watching Lisa, her channel. Appreciate everybody coming. I do have some things I'm going to be talking tonight. It's going to be pretty fascinating, actually. Working on my website. What website? Our website. But I wish, if I had one wish in the world, I wish I had a time, all my time to be able to dedicate to that website and write this stuff down. Trying to get a team together, it's tough. A lot of times you have to do things yourself. So, hey, and it says I brought a friend and. Friend, you are not late. Okay, cool, very good. Appreciate everybody's coming by. I'm gonna wait just a little bit. Like I said, I'm working on Science Woke. Got an article that I've read. I've told you, I think I said this, that in my opinion, it's probably, I was talking to a friend of mine at work who actually follows the channels. Robert Berger. Hey, Robert Berger, to the bang, a Brazilian guy. But a very science woke guy. Really enjoyed talking with him. And I said, Robert, I have written an article that I think is one of the best articles I've ever written. Probably the best in 10 years, if not more. But I'm putting it together on the website. It won't make sense unless I put it all together, and I want to sort of launch it all together. So anyways, I appreciate everybody coming. And I got 4 people already. That's good. Because actually it turns out that these are watched quite a bit, so watch times are quite long on these, so very good. I appreciate you guys who are watching this, and I'm going to get right into it since I know people who are watching this recorded do hang on, because it can get pretty interesting. But today I'm going to talk about something very interesting, which is the quantum eraser experiment. Why am I even talking about this? Well, the reason I'm talking about this is because of this word right here. Let me see if I can make this bigger. Yep, you can see the word right there, quantum mechanics. One of the areas of science, if you watch my YouTube my YouTube video on the major problems in mainstream science, quantum mechanics is one of them. And some people are asking me, like, why is that? And I think the quantum eraser experiment is probably the best example of how quantum mechanics is just absolutely screwed up. So I'm gonna, let me make sure, get my watch here, get myself that I'm offline here with my phone. We'll go forward. Theater mode. Oh, I love technology, is great, All right, so we're going to talk about this, and before we start to talk about it, I want you guys to watch a video. So let's do it. Obviously you have audio, so I'm going to switch over to this. I will put these, in fact, let me, my goodness, hello, I'm going to give you the link for it. I'll get the link for it. I'll put that in the below. But for now, we're going to watch this because it's quite, when I first saw these, I really couldn't believe people get on and talk about this. This has over 1 million views. It has over 1 million views, this. But you got to listen to this thing, how absurd it is. We are definitely in a paradigm shift. I have that article I wrote about that, which I think is a seminal article using Thomas Kuhn's own Kuhn cycle. So let's take a look at this. I'm going to mute myself. I'm going to unmute this, and we're going to go forward. So you may hear a little echo really quick, but then we're going to go forward and watch this until I can't stand it any longer.
This episode is sponsored by Audible. Can reality be adjusted after events have occurred? That's the unsettling implication of the delayed choice quantum eraser experiment. We recently talked about the weird results of the single particle double slit experiment. They imply some startling things about the nature of reality. Today, I want to talk about an additional, possibly even stranger version of this experiment, whose results force us to reconsider the nature of causality itself. Now, this episode isn't going to make a lot of sense unless you've seen the first one, so go ahead and watch it if you haven't already. I'll wait right here. Okay, so the single particle double slit experiment suggests that things may not exist as well-defined, even real particles in that strange interim between creation and detection. There's a fuzzy space in which we don't know the particle's location or path. The Copenhagen interpretation would tell us that in this space, a particle is only its wave function, a distribution of possible properties. It's a probability wave that does all the usual wave-like stuff, like making interference patterns, until something happens to collapse it. At that point, the Copenhagen interpretation tells us that a true transition happens between wave and particle. But is that right? And if so, what really causes this transition? Does observation of the particle's location force the universe into settling down and deciding which particular reality we happen to be in? To head off any wild metaphysical giddiness, I want to say right now that there's absolutely no reason to believe that observation by a physicist is better at collapsing wave functions than observation by an electronic detector, or a houseplant for that matter. We'll talk about what observation really means at a later point. But it's still pretty interesting to see what happens if we try to observe the wave function at different points in the double slit experiment. The great mystery of the experiment is that very particle-like things appear to traverse both slits simultaneously.
I do want to say just now that before you guys go bonkers, we have answers to this. We have real answers to this. So for those people who have never seen this, it's important that people watch this. So I'm not going to go the whole thing for sure. I just got to get to the point where we've got enough information for those people who haven't seen it.
Like you might expect of a wave, physicists love a good mystery, and so have tried very, very hard to peek to see which slit these particles actually travel through before they produce the famous interference pattern. Turns out the universe is onto us. Any experiment that determines unambiguously which slit the particle traverses destroys the interference pattern. Instead, particles land in simple clumps, one for each slit, as though they were traveling as simple particles the whole time. This is even true if you place detectors on the far side of the slits, after the wave particle thing should have already been interfering with itself. It's like the wave function is collapsing retroactively, as if the universe is saying, okay guys, the human figured out which way you went, no more funny stuff, better pretend like you were particles that whole time. But there's a huge problem with this interpretation. It's impossible to make these measurements without messing up the wave. The interference pattern happens because the waves emerging from each slit are what we call coherent, which is a fancy way of saying that the relationship between the waveforms emerging from the two slits, so the locations of peaks and valleys, is predictable and stays consistent as the waves move forward. This coherence is what allows the waves to produce the interference pattern in the first place. But when you place some device in the path of either wave, you mess with this coherence, and so affect the pattern that reaches the screen. By the way, the double slit experiment where you try to determine which slit is traversed is called a which way experiment. And if the test is done on the far side of the slits, it's called a delayed choice experiment. Physicists hate being outsmarted by the universe, so they've come up with clever ways to measure which way the particle travelled while still preserving coherence. I'm going to talk about the most famous, performed in 1999. This experiment made use of a very special type of crystal that absorbs an incoming photon and creates two new photons, each with half the energy of the original. These new photons are twins of each other. In fact, they're an entangled pair, so fundamentally connected in strange ways that we'll come back to. So, place this crystal in front of the double slit to make coherent entangled pairs of any photons passing through. Send one of each pair off to the screen to produce our interference pattern, and use the other to figure out which slit the original photon passed through. Let's focus on detectors A and B here. Detector A lights up if the original photon passed through slit A, and detector B lights up for slit B. If we run this for a bunch of photons.
Okay, folks, I'm going to interrupt here. And I'm going to start talking about what is actually going wrong in this, and how it's absolutely amazing to me how they go off and make these conclusions. So basically, there's a number of things going on. They can do an experiment where they're shooting the particles through the slits, and when they're shooting the particle through the slits, they can measure. They can put a detector before or after. If they put it after, what they say is it's still, oh my gosh, it's not doing it. What the idea is, I'm going to put a detector there, and I'm going to see which slit the particle went through. That was the whole idea. And when they put it ahead of it, then of course they'll know, because hey, it's going to go through that one. But if they put it behind it, it still seems to come with the same behavior of changing what they say, light going from a wave to a particle. This history erasing experiment, the quantum erasing experiment, what they say then is that the way they explain that is that, oh, it's observing. So if you notice, he said, it doesn't matter if we observe it, or if a detector observes it, or a plant observes it. The truth of the matter, it absolutely does matter what they're using as the detector. That's one of the answers. Second answer is they don't know what a photon is, because they have no model of a photon. They have no model or explanation to the particle wave duality. And guess what? My father, in 2015, after 20-some years of looking at particle wave duality, my father came up with a solution to it. Is it the solution? I don't know, but when I saw it, I was floored for like a year and a half. And that really started us on the particle model. And guess what? We can explain all of this. And I'm not here. Remember, I told people who were here before that I would talk a little bit about the particle model. Well, it's because we actually look at these things, because if you have a new model of the universe, you better be able to explain these things. So what's going wrong here with the double slit experiments, with quantum erasing experiments? Well, they're making interpretations that are wrong. They're saying entanglement. What is entanglement? Entanglement to them is they're going to make a photon of half the power and send it through both slits, and they're both the same. They know about each other. I'm going to explain to you in our model what's really going on, and that mistake by them is because they don't know the difference between a photon or particles, light as a wave, or a particle. That's the problem. And because they don't know that, they get all these weird things and interpretations that go on. For instance, this idea that, well, if I put the detector after, it still seems to be able to know that when you go through, when I'm observing it. So it still knows that. And even though I didn't detect which one it went through, and we make sure, they call it cohesive, that we're sending it through, and it's not, it still seems to make it change from a wave to particle. The answer is so ridiculously simple, it's scary. But from that, then you get explanations, and I invite you guys to watch other ones, because you get articles, or look up articles. When this came out, they were writing articles like this. No lie. No lie. There's a photon that's 10 billion years, 2 billion years ago, that was let go. And because depending on where I look or how I look at it, who's observing it, it could go around a star one way, or it could go around a star another way. And they said, this happens. So I look at it 2 billion years later, and somehow that affects how it traveled around that star 2 billion years ago. Now, if you think quantum mechanics is not sick, is not in crisis, as Thomas Kuhn says, you have normal science, then you have models that model drift, you have then model crisis, you have then model revolutions, then a paradigm shift. And so what's happening here is that these people, because they don't have a model, are actually talking about they can't justify 7 people looking at the same photon that would be coming from somewhere. And so if I look at it, it will go around the left side of a star, and if you look at it through a telescope, it's going to go around the right side. So which side does it go around? And this all comes from the idea of the double slit experiment. So because they have no model for what light or light is, they can't explain the light particle wave duality, can't explain it. They put a detector in, and of course they can't explain light at all, so they're calling photons a half a photon. They're talking out their bunda, as we say in Portuguese. They're talking out their behinds. I mean, it's quite striking. And then when they go and put the detector after, the philosophical arguments that they come up with are something that is just absolutely absurd. It sounds like Harry Potter world again. And this is how we know science is in a crisis. Because these people actually, this guy stands here, he's got a 14.5-minute, and he says, oh, by the way, this is all going to sound crazy unless you see the video we talked about before. This sounds crazy. This doesn't, on a scale of 1 to 10, in my opinion, the quantum eraser experiments are 10 in ridiculous. Absolutely. So if you read some of these articles and watch some of these videos, if you watch people talk about lectures especially, these people go around and lecture this stuff. It's amazing. They will say that some of the conclusions they've come up with is that because one individual, we can't have every individual seeing something differently. So there's a collective consciousness of beings. Collective consciousness of beings, and those people and those beings will decide in some detector way, because we're detecting it by looking at it, because plants are the same as us as the same as detectors, which is not true, and I'll get to it. Then we have these amazing things like the reason that photon went in this direction, because there's beings with the ability to observe, and the collective consciousness of those makes that go around. Now, if you're a person like a new age kind of person, energy, then more power to you. But right now, what I worry about, and we science woke people worry about, is the actual physicality of really what's going on. So let's let's get rid of this guy, because I can't take this anymore. And I'm going to show you a place where you can look. I think we may take a look at this. I'm not sure. But my dad has here on his channel, if you go to, I'll just type it in here, youtube.particle.guru, no com, youtube.particle.guru, you get to the Particle Gurus page, my father. And on here you're going to find playlists. And on here you're going to find one that I just actually made right before this, because he didn't group them in this way, but he has something on the double slit. And I'm going to stop it here, but he talks about it. I'm going to go back and take a look at, I think he's got one of these slides, and just if I look at his videos in general. Let's see here. There it is. I'm going to take a look at this. Okay, I'm got it on mute, so let me see if I can go to his solution to the wave particle duality. And actually, this is, I think there's even a better one. Let me go to that. I believe, I think it's in this one. It's got a nice diagram. I apologize. That's what I'm doing on the flies here. Here, is this it? Yeah, okay. Here we go. This one is part 4, light dispersion, and this is his solution. I'm going to explain it to you in the best way I can. In our book, I have a picture of this in our book we're writing. It's in its 3rd revision. And we've never published it. Well, some people have some versions. Here's the solution to the wave particle duality. One solution. In fact, the only solution I've ever seen. And here's the way you can think of it. It's gravity and light. So gravity and light, according to the experiments we see, arrive at the Earth at the same time. So when you look at an eclipse, that the actual gravity effect of an eclipse arrives at the same time as the light of the eclipse. And those two things, therefore, would travel at the speed of c. And therefore, we have the conclusion, if it travels at the speed of c, then it must be the same particle. And that's what the particle model says. And in that, basically, gravity, there's 2 ways you can look at gravity. If you turn your shower on, and it's just random particles, that's just a pressure that's hitting you. It's like, if I just push on your shoulder, and I just push on it, no change, just a push. That's what gravity is. Light, on the other hand, is when you turn your shower on to shower massage. It pulses. So the only difference between light and gravity is that the light comes in groups. And if you look over here, we made it into something extremely idealistic, because over here on the right side of my father's slide is a bunch of lines. Basically, they're just sort of lines representing, you know, groups of stuff. We think it's much sort of more random like that. It's not perfect, but if you were to line things up, they're like bombers. So if you have waves of bombers in the sky, those waves are going to hit you and hit you and hit you. That's what light is. Light cannot be therefore one particle, a photon. It's got to be a plurality. That means it's got to, for light, the difference between light, that's the reason you feel heat from it, is because you're getting, if you want to fatigue something and break something, if you want to break something, I can take like this, and I can keep bending it, that's going to, and that's like hitting it. And if I just do this, that's what gravity is. If I keep doing this, well, it's hitting it in waves. So if you look at these diagrams, you have waves of particles, and they come in frequencies. So if they come in, so it's like, those are waves. And those can be, and you know what's really funny? In the digital world, in fiber optics, that's exactly what we do. We use light, and we say it's in waves, but no, we're using light in waves of particles and in our model, and so we literally send pulses. It's the same thing. That's the answer my father came up for the wave particle duality. Told him, and 2 weeks later, he came back to me and says, "You're right, Dave, I did solve that. I didn't know that." So that's the difference. So you can't have a photon. So let's go back to entanglement. Let's see if we can go here. Quantum entanglement. And if we go back to quantum entanglement, where they start explaining how one particle knows what the other particle is doing. Look at this stuff. It's just amazing. And it's all predicated on the idea that when they shoot in this laser, we shoot these particles, or these photons, that they're shooting a lighter photon, whatever the heck that is. And that they both go into the two slits, and they both know about each other. They're entangled because it's really a photon, and somehow they split it. What we say in the particle model is what we would say is that no, what's really going on is we're sending waves of particles. So they're particles that are sent in waves. And when you get to a detector, and I'm going to go to that now. I'm going to come back to you guys. I know you're asking questions, but I want to get this done. If I go to playlists and the double slit, if we go to the double slit experiment with detector, I will explain to you why we can explain why things change from a wave to a particle. So here's ours. We have a bunch of particles that come in waves. They actually go through the slits. The slits, here's the way you think of the particle model. Everything works like gravity, everything. So the G2 particles, the G1 particles, let's just call them photons or electrons or whatever you want to call them. We call them just G1 particles, just G1 particles. G1 means the particle that goes at the speed of light. It's gravity, it's light, it's electromagnetic fields, it's magnetic fields. It's all the same because they're all traveling at the speed of light. So if you're sending those in waves, you're going to get, what happens is you're going to get patterns here. What's going to happen if you send them, even if they're just like a laser light, what's going to happen when they hit those slits, they're going to bend out, they're going to fan out. Why? Because in our model, you can't just have magical things happen, that there's another level down. Think of these as a gigantic thing in a galaxy, a gigantic structure in galaxies that's the size of planets. And these and these comets are going through. They're going to go through the slit. Those slits have gravity, but in our case, it's a gravity one level down. So the G1 particles, you can move up to comets, and then our G1 particles in our solar system is what makes gravity happen. So if I'm sending these comets through this gigantic slit that has gravity, they are going to be deflected. Now, that's how our particle model works. If you put a detector in, not a plant, not a banana, not a human, they put in a detector. Guess what the detector has? It's made up of G1 particle field. You turn on the detector, it's got electromagnetic field all around it, which are G1 particles, so you're going to interfere with it. Doesn't matter where you put it. Now, I'm not here to preach to you that the particle model is the best, even though it is, and it's the greatest thing. No, I'm not here to tell you that. What I'm here to tell you is this is a model that we know. From what I can see, it's the only real solution I've ever seen to the wave-particle duality, and that's what our model is based on. And then when you look at these experiments, when you shoot what they think they are shooting a photon, they're shooting photons. If you want to interpret a photon in the particle model, are groups of G1 particles. And so that's what's happening. So when you send, there was a guy, he's a photonics expert. Who's that? That's a person who studies photons their entire life. He was at a conference, at one of our conferences once, and this is what he said. He stood up to all of the science woke people, and he said, here's what he said. He said, this is what we know about photons. He goes, remember, I've spent over 30 years studying photons. This is what we know. Somewhere in the universe, something releases a photon. How that happens, we have no idea. What a photon is, we don't know. But somehow that travels through space. How does that happen? We have no idea. It gets to our detector. And that photon triggers our detector. And how does that happen? We have no idea. Why was this guy a critical thinker? And in our conference, a conference that was talking about the Big Bang's wrong, relativity's wrong, particle physics is wrong, quantum mechanics is wrong. Why was he there? Because he's a true experimentalist. And he knows that he has no physical model for any of this. So that's the problem with quantum mechanics. It has no physical model. Therefore, the double slit experiment can't be explained. With a detector, even less. And then they go off on philosophical journeys that make you scared. I would be embarrassed if some advanced civilization came here and heard or even read about this. Even went and they looked at entanglement. So, anyways, let me go back here. I can see, I'm sure got lots of people. Okay, I appreciate you guys all coming here. And now I'm going to go through some of this and read it a little bit, see where we're at. I'll go back here to the quantum erasure experiment and see what you guys are saying. I apologize. I just wanted to get through that. Okay, English fellow. Okay, piano. Hey, I appreciate it. Piano man. Hey, piano man. I like the piano. I was raised on classical piano. I can play a little bit, but it's a little bit out. So I'm sure you play way better than me. We are just finishing dinner. Okay. Hello, David. Hello, Greg. Pleased to meet you. Looks like you're a friend of Lisa's. You hearing videos? Yes. Oh my gosh. Please not. Yep. I listen to PBS and NPR. I can't listen to the politics on NPR because it's so biased and they pretend not to be. I can't. I'm a progressive. Voted Bernie Sanders, Jill Stein. But regardless, vote for somebody who cares about us and not the corporations. But regardless, you know, when you listen to these things, it's really almost impossible for me to sit through Discovery Channel or these types of videos because I want to kill someone at the end because it's so far off. Let's see, nothing, a shadow color, okay, nothing isn't, I hope you're exempt. It says, as I look at it, the YouTube video linked, I laughed out loud, it explains itself. Sounds like the adults in the Charlie Brown, yeah. Observing photons with photons, of course, would change propagation path. Yeah, I think Feynman made it clear that in one of his early lectures, absolutely. Like Feynman, he said something that you can keep on creating with math to prove a point that could be an issue, paraphrasing, of course, yep. Alrighty, hopefully I understand, okay. Nothing, it seems at least all right, okay. Proof of, just need a proof of gravity. So far, a ton of them come in, all are related to another thing, weight, magnetism, electricity. They don't even know what spin or spin down means. Yep, absolutely. You want to hear spin, isospin, half spin. That's a good one. I actually had someone explain to me what half spin was because I didn't know it. Get this. Here's half spin. Okay, this is spin. Half spin is when you just like this part because it's halfway up. I can't believe they said that to me. Someone did. See, it sounds like a great question. I'm sure, did Feynman say things about gravity too? Yep, Feynman did. He also spoke about what magnetism is. Nothing. I looked at several books. I found it entertaining, but I don't know exactly this as jazz. So Dave is saying that literally based on nothing, just sort of guessing. It's not based on nothing. It's based on the fact that they don't know what the heck is going on. So in their world of particle, it comes down to, again, I'll say it again, it's the wave-particle duality that they haven't solved. And they have to understand that when you put a detector, it magically changes from one thing into another. That's like the neutrinos that fly through space, which don't exist, but fly through space and change. They call it oscillate into other ones. It's because they have no model. Look at the Kuhn cycle. Normal. It's in my article. I can't get it out there. I need someone to help me with my website. All right. It seemed philosopher didn't science, physics boot those people. Just to get people to understand, our organization's called the John Chappell, named after one of the modern organizers of dissident science, who started this group back in the early 90s. And we call it natural philosophy because that's what it used to be called before they called it physics. And the reason we do that is so that we go back to when we think the science wasn't screwed up, which is basically 1905. Who was that, Mr. Albert Einstein, and his inventing and imposing rules upon the universe? In my article, that's why I can know all of this. I understand you. These guys are number one propaganda. I feel sick watching their black hole crap. Yeah, it's pretty sad. Tried to read a universe from nothing, but I could not get my head around it. I'm glad now. Yeah, you don't. Okay, let's keep going here. Nothing isn't as it seems as it becomes. No shenanigans of science. Very wide open. Nothing as it seems. Yes, deserves having coffee one day. He seemed to be raised in a piano, listening to Rachmaninoff. Alrighty, guys. So I'm going to just keep going here. What I want to stress to you is to pull back again one more time, and that is quantum mechanics is been taken over by this double slit experiment, which has been neglected because of it doesn't have a model for anything. In fact, the standard model is a joke that they call it a model, because there's nothing a model about it. I've explained that to people again. I'm going to do this. I'm going to look up quarks. I'm going to talk to you. I forgot to talk about one other thing. Here's the picture of a quark. Here's a picture of a proton, I believe. An up and then two ups and a down quark. And you know what these are? Gluons. They glue them together. This is how little we have of a model. We don't know what the size of them are. We don't know what the shape of them are. We say that a proton is round, but how could it be round if it's made up of three other round things? And what are gluons? They keep it together. And in fact, Dr. Bill Lucas, who knows some of the best particle physicists around, I guess, they've already looked at the data and said that the strong force doesn't exist. Now, how does certain models you can read and look at? Jeff Yee, his model, the energy wave theory. You can look at his model. You can also look at our model. We don't have quarks. We've thrown them out. We don't know what is there. So, anyways, this is the state of modern particle physics. The standard model. And there is nothing in it that's a model, because to me a model has to be physical. And there's nothing standard about it because they have anywhere, it depends on who you talk to, 19 to 23 free variables. What does that mean? 19 to 23 knobs, which they can turn so that they can make the model work the way they think is. And the biggest thing they worry about is what they call symmetry, which is if you got a positive, you got to have a negative. If you got to have anti-quark, you have to have a quark and an anti-quark, and proton and an anti-proton. It just goes on and on. So, concerning the atom, is it possible that they're all linked to atoms, or that all linked to atoms are that all linked? I'm not sure I'm understanding. Nothing, Lance. Can you maybe say that again? It says it seems concerning atom. Yeah, probably. I'm sure maybe you speak another language, no problem. So I'm trying to get your English there. Is it possible that all linked to atom or dipoles? Okay. You want to talk about dipoles? Let's do this. Here's something you guys should see. Go to YouTube. Go Yonel Deneau. One of the aha moments of my life. I think I only had 3 of those in science. One was with Yonel Deneau. One was with Glenn Borkert, and the other one was my father with the wave-particle duality. So Yonel Deneau, one of the great physicists of our time, he's an etherist, and he has these most amazing videos around, let's see, unraveling the nature of radio waves. Let's see, let's just go to his playlists. Unraveling the nature of magnetic, okay. Here we go. Here we go. You want to know what magnetism is? This is what it is. This is our model. We explain it actually in a
in this experiment, we're going to start the motors, which are going to rotate the cylinders in opposite directions. Let's see what happens. We start motors now. We see that the cylinders attract each other and now are...
So, this blew my mind. When I saw it, it was one of the greatest revelations I think I've seen in science. What's happening? He's showing that fluid around some object going in opposite directions causes attraction. So what does that mean? That magnetic fields, electromagnetic fields, are flows of particles. And my dad and I, in our book, it took us 2 years of hacking the universe. But I'll get to that. Let me see here. I'll just go here. Hacking the universe. We actually can explain that, what's going on, using I don't have the poster. Ooh, I wonder if I have my poster here. Let me see. Poster.universehack.org. Let's see. Oh, look at that. The amazing G1 particle. It is a poster. And here you have particles that are going around and round and round. When those particles go in opposite directions, they cause attraction. When they go and collide with each other, they cause repulsion. So that's what he's showing here. So if you want to know what magnetic fields are, let's just keep going. Let's go and show.
Sticking to each other. Let's try to separate them. We see them attracting each other again and sticking to each other. Let's stop the motors. Observe that they attract each other. We observe that the cylinders repel each other. Their relative distance is increasing. Difficult to make them approach each other. We see that there is a force which is acting so that they repel each other. This force is obviously due to the water, which is set in a motion of rotation.
If you guys aren't blown away by this, you might as well just give up loving science, because this is absolutely a fantastic discovery. It's just absolutely fantastic. In fact, like I said, it took us 2 years, and actually the explanation of why this happens. This is a little different because it's dealing with liquids, but let's see if he has another one here. Hold on. Oh, here. This is really fantastic. Let's take a look at this. I'm going to leave the music out of it because he didn't do any voiceover. So I'm going to mute that. So here's what he has here. He has two... oh, let me mute him. Sorry. He has two... Those are magnets, and you can see what happens. The north and the south attract. You can see there he's using the directions. So this is a really hard experiment to do. He's got to have rotating blocks of wood, because he has, you can see the weight that's tied to it. and he's going to spin those underwater. And you're going to watch how those things act exactly like magnets. There we go. See the ones below? I mean, this is like super obvious and easy to follow. So look at it again. They're going in opposite directions. That's why the north, what they call the north and the south. The north and the south are the same as positive and negative. They're just a way to label attraction. Doesn't mean that's what's causing it. Watch what happens. See how they're resisting each other? So now he's putting them next to each other. You can see that when you put them together, they bounce out over, and then they end up flipping and attracting themselves to each other. Well, look at that. That's exactly the same thing that's going on. Okay. Anyways, you can see that. So, for those who want to know what magnetism is, he actually has a his own ether theory that talks about that, and that's quite incredible. So, anyways, that was my spiel for today on the quantum mechanics. So, you know, and charge is the same way. Charge plus and minus are just notations. Flow of electricity is just notations, even though there's a flow of particles. Magnetic fields are flows of particles. If you look at Lionel Deneu's, the newer, he starts getting into ether and attraction, that kind of stuff. And so he's doing more complicated stuff where he's saying which way the ether's flowing in these situations. Now, for those, I'm not sure if this may be a little bit beyond, but when you look at actually what's happening in the mechanics involved, the thing about the cylinders and everything actually use gravity because the gravity's pushing on the water, and that's one of the things that causes things to work in the correct way. But if you look at it in just like, there's never empty space, but at least pretty empty space, that you're going to get the rotations causing attraction and repulsion. And of course, then what does that mean? That means all magnets just have flows, particles. The Earth has flows of particles. They go, according to our model, they come inside the South Pole and go out the North Pole. And that's why you can have mass increase in the Earth, because you have protons, or what we call nucleons, that get blown apart, that are free nucleons flying from the sun and other suns. They get caught up into the G1 particles. Those things then create new mass inside the Earth. But that's one idea. Nikola Tesla, I think he's popular in the chat for some reason. Maybe I'm wrong. So the text says, has Magnus type effect from fluid motions? Yeah. But I think one of the interesting questions is Mr. Tesla, right? I've talked about this before. One of the things he wanted to do is transmit energy, and he thought he could do that at a very long distance, and that was one of the things he worked on for a long time. That's what this Tesla's Colorado Spring Laboratory, here it is, this big guy. So he was, trying to build this and then send it out. Now, he's got the same problem as everybody else, and that is he had no model for what light is, for electron, radio waves, power, anything of that. So he was doing experiments, but If you don't have some model at this level, you're going to fail unless you do have a model. And the model will tell you in this fact that what he was trying to transmit and the way he was doing it wasn't an effective way to go about things. So, yeah, Wikipedia, yikes. Wikipedia is the consensus of everything, which means, of course, any new ideas will be banished. So any questions? It looks like you guys are all here. I appreciate you coming. And fact check: the magnetic north is geographic south, etc. Again, unless you have a model and you have some explanation, north and south are actually, in fact, I think the compasses are actually written backwards because in order to point north, it's not the north of, it's actually the south side of a magnet. So they have to paint the south side of their own system's magnet with the north to make it work right. Yes, we actually had a conference with Tesla Tech. I think it was back in 2000. Ooh, don't remember. 2008, 2009, 2007, 2006, around there. I can probably look it up. Natural philosophy. If we go to our website, we can tell you we did have a Tesla Tech, because when we were in Albuquerque, New Mexico, we actually were with Tesla Tech. And I had a very interesting discussion because we had an open session for talking about gravity. I'm sorry, I think I've got so much up here. Let me take this stuff down so that we can go faster here. Go to conferences. And we were at Tesla Tech. And where was this? College Park. 2016. Albuquerque. So that was in 2008. Yeah, I was right. Oh my goodness. 2008, we were in Albuquerque, New Mexico, our conference, and we had actually a simultaneous session where we invited people from Tesla Tech. And those guys are pretty much, how do you say, they're more tinkerers in the garage, which is great. I love tinkering. I love making things. We had 88 abstracts. Whoa. Yeah, that's when we had our big abstracts. Our display isn't very good. I have to work on that on this website. But anyways, what happens when we had a discussion, they get into their vocabulary, the people who are sort of more new age, those people who are tinkers in the garage, they talk about energy a lot. Energy. There's energy here, and there's an energy field here, and they tap into that energy and 0-point energy. If you know, and if you really look at the philosophy of what energy is not real. Energy is a concept we use to try to describe useful work that we can get from a particular mass of stuff, gasoline, plutonium, water, even if you're doing vapor, that kind of stuff. So when we talk with them, I started to try to get them to back off on their vocabulary and start saying, okay, don't just use these magical words. What you want to do is you want to know what those words mean. And so that when we talk about energy, we all understand that it isn't a thing. Give me 5 energies and put in my hand. Can't do it. In fact, if you watch my movie, did some people watch? Oh, I don't know. Lisa probably hadn't had time yet. Hey, Lisa, did you give time to watch my movie? It's okay if you did. It's entertaining, actually. But in my movie, I say I can make you doubt E equals mc squared in 3 words. I can make you doubt it. So, anyways, this message is held for review. Socrates. Let's see what this is. Okay, he's looking at the north-south. Okay. Alrighty. Let's see. It says I might follow Spirit Science because they give good info. You know, you get a lot of good info in a lot of places. A lot of our scientists are creationists who believe the Earth very young, but I don't care about that because they're not reporting on that normally. They're reporting on other things for their models. So never look at stuff that looks crazy or whatever. You can get good information anywhere. Let's see. Not yet, Dave, but it's only because I've been under the weather all week. Yeah, I can understand that, yeah. But it's entertaining. And if you want to watch my movie, let me know. Send an email to this email. I'll just do it at this, Einstein. David at einsteinwrong.com. Then I will send you a free viewing of it. So I will do that for you. Let's see here. einsteinwrong.com. I've got to get an interview with my composer. He's really cool. This is my website for the movie, and you can see here the story. Oh, the cast. There's the cast of the movie. Dr. Edward Dowdy, Dr. Eberly Spencer, Dr. Cynthia Whitney. There's actually more. I need to put Peter Marquardt in here. He's pretty cool. What else we have? The cast. We have the crew, I think. Yeah, crew. Great editors. Andrea Tucker Van Meter and Nick Tambury. Great editors. Jack Sherman. He's done a lot of great stuff in Hollywood. And of course we have our cast of the... So yeah, you can say it. You know, you can actually buy it. You can rent it for $3. I think $2.99 or something like that. Anyways, that's that. How do you want to Skype sometime? Yeah. Hey, do you want to Skype sometime? Yeah. Well, let's do like a pre-interview. That's what we can do, Greg. Absolutely. Proto-X, tudo bem, cara? Brasileiro, tudo bem. If you want to vet .info like Spirit Science, look up Spirit Science Debunked. It is by Cool Hard Logic, YT channel, by the way. Can you rent it on YouTube? Yeah, you mean no, I don't have it on YouTube. It's on Vimeo. If you go to it, if you want to watch it online, it is on Vimeo right there. You can watch the trailer. Hey, we can watch the trailer, I think, here. Let's see if we can. Oops, that's not good. I don't want to do that. I think I can do it this way here. Trailer's 1 minute, folks. Let's see if I can get the sound and everything. And I'm off.
Ladies and gentlemen, boys and girls, what you're about to see is out of this world. Step right up now, don't be shy, because we're about to show you how cars can fly.
You heard the title, Einstein is Wrong. So we want to know if you agree with that or disagree with that.
Yeah, I very much disagree with that.
Every day I see a bright blue morning, the sun shining as the world wakes again. Hey mister, can you tell me, does space bend?
Speed of an object with respect to an observer who is off the line of motion to the object. Whoa!
Joyous people celebrate
no clue.
life so grand. Hey mister, read that fairy tale again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day.
There you go, folks. My trailer for the movie. I actually have a music video. I think I'm probably the only serious music science documentary that not only has a music video but has a theme song, which you heard there, which is a great theme song. I have the track here, I think, somewhere. Let's see, story. Oops, no. I've already played this. I'm not going to bore you with that again. But it's here. Poster, no. Watch now. Oh, soundtrack, yeah. so you can listen to the soundtrack. And I don't have the music video, but I think I have that also somewhere. We kidnap. Have you guys seen the video? We kidnap Stephen Hawking. Watch now. There's YouTube channel. Oh, that's me. That's my. Watch now. Let's see if I go to that one. Oh yeah, there's the music video. Watch online. There's the Dissident Science. There's the trailer. And this is pretty cool. If you haven't seen this. I actually had a podcast when I started. Actually, Lori Gardee found me on the podcast, and that's why I started doing this channel, because people were listening to my podcast, and I only did a few episodes, and like people started sending me emails. All of a sudden, I was discovered on the podcast. It's like, Dave, why don't you do more? And I said, okay. So, so we'll watch. It was actually something. The most weird story about this is that I actually filmed this as just a concept that I had, which was an opening to the film where I wanted to kidnap Stephen Hawking and put a gun to his head and make him tell the truth. But anyways, I'll just play it a little bit. I remember when I first did this, I had a lot of emails come at me that I was so how do you say, disrespectful to Stephen Hawking. But the whole idea, actually, it turns out the funny story to this one is that actually my idea was, I've had several ideas of putting people in court. In my film, in fact, I was looking to get a courtroom and put Einstein on trial. And then also, I also was thinking about, you know, the kidnapping. I was also thinking about wrestling. I was thinking all kinds of stuff. And I actually, just a couple months ago, because of the news program I did on dissident science, it somehow warped in my mind into the answer I've been looking for that could really bring millions of people into the science woke world. And it was all because of this. It was really interesting to know, too. I shot this 2007. The music was written in 2013, and it was not written for this video. So go figure. You talk about pretty wacky stuff. Anyways, I thought that was interesting for those people who had some questions about the. Alrighty, you know, any other questions as to why the flux lines entering and exiting? Which way are the flux lines exiting and entering? Compare the pictures. Be very careful. Be very, very careful. And let me tell you why. You know, it doesn't matter which one of these you look at. Be very careful before we all go running off, because there's a couple of things. When you see these shavings, for instance, that are put down, are these the results of the actual flux lines? Are these what the particles are doing? Or in fact, is this the results of the flux lines that cause the shavings to give us those formations? So be very careful before you go off thinking, oh yeah, I know all about magnetics and all that stuff, magnetic fields. I see Yonel Deneu's stuff. You got to model it, and when you model it, Yonel Deneu has a different model of the flux lines of ether. We have particle model. He has an ether model, and we have different ways to produce these. So you got to be real careful when you look at these things and you start, you know, talking about them. These are not necessarily the flow of, for instance, the G1 particles. If you want to know about that in our model, then you would go to, you know, youtube.particle.com and look it up. Watch my dad's videos. He talks about this. But anyways, be very careful when it comes to these flux lines and everything. Okay? I'm just saying. A protext, what is the reference for acceleration? Okay, so you guys are looking at something here. I'm going to take a look at it. I'm not going to be able to put it because I have the chat on a different computer. I'm going to take a look at it. Okay, so you're looking at the flux lines. Okay, let's take a look at that. Oh, this is cool. I guess this is sort of like probably really measured and stuff. That's really cool. Computer simulation of the Earth's field in a period of a normal polarity between reversals. That's really, I've never seen this. This is really cool. Well, let's go back to this and look at images like this, and I'm sure we'll get, there we go. This is the one I think you're seeing here. Yeah, that's the one I think you guys are seeing. It's actually got a geo North Pole and a geo South Pole. Let's see if I can find that one. What is it? NASA, Sun, Earth, News, Magnetic field lines. I'm going to talk about this. Is this the one you guys are looking at? Is this it? I'm going to ask you there. Hello. I don't want to. I'm watching the chat here. I'm seeing the people online must be like, oh, we're watching this recorded. Sorry about that. I am like not talking. I need to keep talking here. Anyways, I think what's actually going on. What's actually going on is in our model, it's actually the opposite way, that the actual particles travel in the opposite direction. So it's just a matter here is that they see fields that are going on. They call it north and south. They don't have any flux. The flux lines that they have, I'm not even sure if they correspond to flux of really anything physically. Again, be real careful, you know, to come here and say, oh, those are particles. They don't say that magnetic fields are particles at all. They say it's a flux. They don't say there's ether. They don't say there's particles that cause these fields. So you got to be real careful when you guys are looking at this stuff. Okay, what is the reference for acceleration? Proto-X. Tudo bem, cara? Agora eu vou falar português e você vai escutar. Can you sort of ask me about? Give me more of a detail what you're asking about. What is the reference for acceleration? Maybe I can help answer that question. Yes, no. Let's see if he says something. Jocko, wow. I'm seeing a classless Stephen Hawking video. I can see why people call you Papa D Hillbilly and Dum Dum D Hillbilly. Oh, wow. Cool. See? There you go. The guy says the video was classless. I guess he doesn't get humor, does he? And in fact, Stephen Hawking, if you've ever read, what's his book? A brief moment in time. I actually do a video. You guys should look at that one. I do a video of that. Say YouTube. Wow, Mr. Jakaha. So that's a really scientific statement you put there, I can see. Sad. It's such a waste of time. I mean, if you don't like me, just don't watch. That's the weird thing, isn't it? It doesn't matter. Guess what, folks? You can't stop being science woke, you can't stop critical thinkers, and you can't stop the progression of science. Those people who laugh at this stuff are basically relegating themselves to the historical flat earthers of our time. That's what you're doing. You're associating yourself to a dead end. That's totally fine. You have the right to do that. Poor you guys. Let's see here. I think there's a search here. What was I talking about? Oh, darn it. Brief History of Time. That's it. Hawking. It's one of the worst books ever written. Oh man, I got lots of it. That's equations. Oh, that's a good one. Oh, you guys haven't seen that one. I bet you haven't seen this one. It's worth it. Before I get back to you, I've got Proto-X. Só momentinho, sim, aceleração aparece em relação do quê? Okay, boa pergunta. He's asking a question about acceleration. I got to show you this one. I made this meme. It's pretty cool. So that's pretty cool. I made that when they were making the Genius stuff. I see Jockey says, I disagree with much mainstream physics, but I would never make fun of someone's physical characteristics. First of all, it's not making fun of any physical characteristics. What we were doing was taking a person who, by the way, was worshipped much more for his physical characteristics than his science. Because his book, A Brief Moment in Time is what it's called. It's one of the worst books ever written. In fact, there was a, I believe, we can go to Amazon, let's do that, and go to a brief history of time, that's it. I believe, a brief history of time. Yeah, I think there's an. I do talk about someone's article or someone's review of this, and it was quite good. He basically says talks about how people are fascinated by. We're fascinated by the story, and this is true. I talked to a lot of people in Hollywood about story, and one of the things about with Stephen Hawking, what was fascinating to the public wasn't that he was a great scientist. People didn't know what the heck he was talking about most of the time. They were amazed that he was in a wheelchair, that he talked through a machine, but as a scientist, he's still a scientist. In fact, we had approached him, several people in our group had approached Stephen Hawking, and he was very arrogant. And he would not answer any questions that questioned anything that he did. And so, no offense, I'm actually the opposite. I treat him just like another person. Now, what the humor was the humor was to kidnap him and to put a gun to his head. Making fun of his disability, that's not what it was. Not at all, not at all. But that's okay. I respect your opinion on it. That's no problem. But I'm going to have to find that. Come on, where is he? 3%. Maybe he's in the 1%. Is this it? I imagine laymen like this book we gave me voluntarily fascinating, weird concepts without noticing that they got no understanding. Anyone with an... Yeah, I mean, basically, you know, his book was just terrible. And there was one guy who did talk about the physicality of the man. And I think that's really why Stephen Hawking was popular. It wasn't because he was good. It's a human interest story. Same way with Einstein. The human interest story about Einstein is what? His hair, and that he was a patent clerk, and that he turned into some genius of science. But unfortunately, his stuff is wrong. It's not used in GPS. It's not used. It's not observed the way it's supposed to be observed by NASA scientists, who you're supposed to see. What they call gravitational lensing, when you don't see it in the places you should. So, you know. Oh, here's one, just so you guys know. We get this all the time. We're anti-Semitic because we criticize Einstein. So we also get that moniker. That is, we are anti-Semitic because we say Einstein's wrong. We get that. We get it. It's been told to me 3 times this year already. So you got to be real careful on mixing what we call satire, for instance, and mixing criticism with attacks, personal attacks. Like I said, like my friend Peter Marquardt, Dr. Peter Marquardt says in my film, he says, I sort of like Einstein. He was a good guy. Yeah, he's wrong. Yeah, I mean, Illuminati Socrates. He says, at the end of life, Hawking seemingly reversed his stance on almost everything. Well, one of the things I do respect him for, one of the things I do respect Hawking for was he actually backed out of black holes the way he was talking about them before. He called them gray holes, but he actually said everything I told and was working on with black holes, I now believe is wrong. Not all of it, but I mean a lot of the fundamentals. So I have to give him credit for that, for sure. Yeah, I mean, Hawking was a mathematician. Let's see here. Oops. Good point. It's very important too, because much of the micro black hole safety is based on micro. Yeah, one of the other great things is, I think one of the most humorous things is in the dissonant world, we were getting really cracked up when we were reading about creative. See if I can find an article on that. We'll get to the news. Let's say news.google.com. When they said they were going to create black holes in the laboratory, and they were afraid that they were going to suck up the whole, the Earth and the universe and all that stuff. Let's see if I can do that. Creating black holes in the laboratory. Terrible speller. This maybe have something in it, but they were talking about where they were afraid of worry. Yeah. I mean, yeah, look at what they're talking about. They're talking about here, like, the paper's referees objected to the dirty joke. Religious people might be offended that scientists were aiming to steal the feat of universe making out of the hands of God. I mean, this is the problem. This is the real problem of mainstream science, for sure. They think they are all big for their britches, for sure. Let's see what else here. Yeah, the Big Bang never happened. Yeah, I've seen that. That's really good. Big Bang's just full of problems. On our website, I'm going to be putting those things together, hopefully. Get rid of some of these things here. Probably eating up cycles on my computer. I'm using an old computer here. Let's get to a... back to my there we go. Let's see what else we have. It says, as I said earlier, from what I can tell, Einstein didn't elevate himself. It's others who have. Absolutely. And in fact, in my secret project, I have that. I actually, it's a creative series, as we can say, and in that creative series, I have actually him flipping sides, and he goes around criticizing his own followers for becoming too fanatical. In fact, I have a meme for that. Where did I put that meme? I think it's on our website. If you go to our website, I got some really great memes. Hey, you guys want some really great memes? Go to our website here, our science. Where it is? Come on, there we go. There it is, CMPS memes. I have something like that. Here I say, Dear Albert, I know if you were alive, you would look at the challenges and problems with your theory and even consider that perhaps you were wrong. Yet many cannot let go and often forget you were in fact a human, not a god. In fact, that sentence comes directly from my movie, from Dr. Cynthia Whitney, who got her PhD at MIT, who's our chief scientist today. Wonderful lady in her 70s, extremely brilliant, and her doctoral thesis was on physics and relativity, and she's a person that's now fighting relativity. Let's see. We live in a fractal universe, as far as I can tell. It's interesting, Illuminati, Socrates, your idea of living in a fractal universe, somewhat correct, because a fractal universe is infinite, up and down. So I agree with you that the idea of fractal is, the way I look at it, is infinite. And so I do agree in that sense. There may or may not be beautiful equation at the heart of it all. Okay, good. Good. How do you say? Discussion point, and that is ultimate particle. You need to go watch my video on the ultimate particle. Can't have an ultimate particle, in my opinion, and other people's opinions. That's why we have to have infinity. It's because if you had an ultimate particle, it'd have to have many magical powers to all of a sudden start organizing itself into the universe. Whereas if you have infinite amount down, everything, anything that's happening at this level, like even electron going around a proton, or whatever you want to call your model, how that works, there has to be something smaller making that curve and space happening. So, but careful. Velikovsky, you will have to forgive me for my butchering the names. I'm going to go to bed. Thanks so much, Lisa. When I go back. Okay. But thank you so much, Lisa. Appreciate it again. And I got to get Protex. Are you still there? Oh, I will discuss it, Protex. Sorry. Dr. David Thumb. I'm sorry, I didn't see some of these. How's Dr. Everly Spencer? I don't know. Protex. Protox. You're asking a question here, and I didn't get to it. Man, I apologize. All right. I got off on that. Okay, your question is, seeing acceleration appears to be relational to what? In relation to empty space, in relation from accumulated mass in the universe, or is it relation to something else? So the question is what's acceleration related to? Very good question. In fact, Andreas Cies, when I first heard of him and him talk, he said, it seems like gravity has something to do with all the stars in the universe, all the things around it. And in fact, that's where this answer is to acceleration. And that is, space isn't empty, so therefore you have, let's take a model. We have to take a model. I can't work in a vacuum. I'm sorry. And I do apologize. We're probably lagging, so let me turn this off. That should help. Do I have anything else up? No. Okay, hopefully the lag will. But anyways, what happens is, if you have the universe and you have a model, and this is one of the reasons I say Einstein's thought experiments are useless, is because he gets rid of everything, and he says, just if I have an elevator, or I'm falling, and I'm in an elevator, I could be in weightlessness, because I could be out in space, or I could be falling in the Earth's gravitational field. Well, the problem is you can't take away the rest of the universe. The moment you throw away everything around it, the universe can't exist. And that's from so the answer to the acceleration problem is yes, it's going to be accelerating against something. And absolutely yes, it has to do with mass. It has to do with with fields of particles. In this case, if you want to call them gravitons, what we call G1 particles, because the gravitons are also the light. You have all the stars. Let's take the Andreas Cies, and then also our model, which we talk, we give it more specific form. So you have all the stars, and they're spewing out huge amounts, and what we know they're spewing out light, they're spewing out nucleons, parts of atoms. All of these things exist in the plane of the universe we're in, because if it's infinitely up and infinitely down, we have a plane of the universe. And so if you have things that accelerate, like in a magnetic field. Magnetic fields, according to our model, move close to the speed of light, slower or close to the speed of light. Those, if you're talking about acceleration with that, if you watch my video on acceleration, I just did that. What you have is like gravitons, and those gravitons are hitting at the speed of light. If you're accelerating a particle, for instance, then yeah, the acceleration has to do with the accelerant, the thing accelerating it at the speed of light, which hits like a proton or a nucleon and makes that go faster, and each hit that it receives, it goes faster and faster and faster. So the G1 particles are pushing it along. And so yeah, it's going to be accelerated according to whatever level in the universe you're in. And if you're in this level of the universe, if your question is a spaceship in space, well, we have G1 particles or gravitons or light particles, whatever you want to call them, filling space in all directions. And yeah, that causes friction. And yeah, that's why we have light that doesn't go forever, because you can't transmit even particles being sent 10 billion light years, and they make it go through the whole universe 10 billion light years and make it to your eyeball. Those things are going to be affected. They're not going to make a straight line ever, and they're never going to be non-affected. So yeah, acceleration has to do with the system around which your model is built, in that level it's built. So you can't really divorce it from the mathematics. You can't just talk about it in mathematical terms. You have to have a full-blown, full universe model, or you're going to actually have problems. So that's my answer. I'm hoping that maybe help. Did that make some sense? Fez sentido, cara? A ideia é muito simples. Você tem que ter tudo. Seu modelo tem que ter tudo no universo. Você não pode olhar a aceleração numa situação isolada. Você tem que realmente, olhar a situação, e tudo está em volta, tudo está em cima e tudo é embaixo, para você ter sua resposta, que é aceleração. Aceleração realmente, para a gente, nosso modelo de partícula, é simplesmente um montão de batizinhos nesse caso na velocidade de luz. Então, okay, just want to make sure people got that. Hey, Russian dolls all the way down. I like that. But Borchert's the infinity guy. Got to read Borchert. Got to read Borchert. Got to read Glenn Borchert. And he talked about turtles all the way down, and I said they're turtles all the way up too. Turtle all the way up, turtles all the way down. Russian dolls all the way up, Russian dolls all the way down. I like it, Illuminati. Very good. I think the logical phenomenological intractable reality is actually that like a fractal actuality in time and space duality. Oh my goodness. Is that sort of like to get on my case about lots of words not necessarily mean as much as you want to think? Message retracted. Time and space have no limit. Yeah, I would say so too. They're infinite. That's the way I would say. Space is infinite. Time movement is actually, time is movement, and everything's moving. There's never anything that's still. Anything you pick up, it's like, it's not moving. Well, it's moving in a spiral way around the galaxy, because we go around the sun, and that goes around in a spiral motion. When you look at it, the Earth's going like this, and then the galaxy's moving, so then it's going like this, and then all the pieces inside are all moving, because they got G1 particles or electrons going around the protons, etc., etc., etc. Okay, I think we're coming up to, wow, an hour and a half already. So maybe we want to wrap this up unless anybody has any more questions. I think I probably drove some people away with my terribleness of my music video. Oh boy. Anything else I missed? The Large Hadron Collider can create a black hole. I made a video on the subject. Okay, Greg Stewart. Hey, Greg Stewart, what's your, let's see, what's your, Greg Stewart, send me your email and videos again. I'm sorry, I've just really been busy. All right, guys, I think I'm going to head off. I appreciate everybody hanging out. Hopefully it's been good. You know, I don't know. You're getting anywhere up to 9 or 10 people at a peak. That's pretty much what's expected for 2,500 subscribers. So that is cool. And hopefully people, I do know that people actually do watch it quite a bit on recording. So that's amazing, because they also have, I also have, man, they average like 17 to 20 minutes people will watch these things, so that's quite amazing. So I guess there are good things going on. Let's see. Well, the best time is a way for us to measure movement. Time, it doesn't exist without movement. The universe doesn't work. No, nothing is. Everything is in movement all the time. So time is our way of measuring movement. Measuring movement, or as Glenn Borkert says, he just says it's the same as time. Time and movement are exactly the same. But I think those are good ideas. I'm still working on these science videos, but I can give you a sneak peek. Okay. Listen, you know, if you're doing stuff, let me take a look at it. And if it looks, you know, pretty cool, and, you know, critical thinking and science woke kind of stuff, you know, we can maybe include you on our list. So, alrighty. Yeah, well, actually, it's okay. It's only 10:40 here, but listen, I'm going to take off. I know I've got, what, 8 people watching, I guess, right now. So thank you so much. I do appreciate you guys. I'm working on that website like crazy. I wish, that's my only regret. I have so much to do in so little time, because I got my regular job in supercomputers, and I'm trying to start a whole new department and get computers, the supercomputers, to be working on reading text and understanding it. It's one of my specialties, but, you know, doing too many things in life. But I think it's really important for me to get out there and get people to understand where we are, because we are in a science revolution, and I got to get that article out. If you do want to help out with the new website, let me know. If you're a person just starting out, you know, any help would be great. But everybody's, I know, so busy. Alrighty, guys. Like I always say, stay critical, stay thinking. I'm Dave D. Hilster, your science therapist, you know. Gonna get you to the promised land of science woke. Ciao for now, guys. See you later. Well, what kinds of best methods to contact you, David? Email is good. David@dissidentscience.com, david@thehilster.com, david@einsteinwrong.com, any of those. Email's the best. That's where I really can have a record of it. So yeah, Greg, love to talk to you. Let's do that. It is a deal. Thank you so much, folks.